Colligative properties are those which depend only on the relative amounts of solutes and solvent of a solution. The following are the examples of colligative properties. We have the vapor pressure, we have boiling point elevation, and then freezing point depression. Boiling point is another colligative property. It is directly affected by vapor pressure, lowering due to the presence of a non-volatile solute. The lower the vapor pressure, the higher will be the boiling point, since more heat energy is required to make the vapor pressure of a solution equal to the atmospheric pressure. The amount by which boiling point is elevated is determined by this equation. So delta T sub B is equal to K sub Bm, wherein delta T is equal to boiling point elevation in degrees Celsius, and K sub B is equal to molal boiling point constant of the particular solvent used. For water, we have K sub B is equal to 0.512 degrees Celsius per molal, and then M is equal to molality, the concentration of solutions expressed in moles of solute per kilogram of solvent, or in molal. Alright, this time let us have sample problem. Our sample problem is what will be the boiling point of a solution prepared by dissolving 10 grams of sodium chloride, or NaCl, in 25 grams of water. Alright, so first we have to identify the given if we're going to solve this problem. So for the given, we have mass of solute, which is 10 grams, mass of solvent, which is 25 grams. Mass of solute, which is NaCl, will be 10 grams per 58 grams per mole. And then mass of water in kilogram is equal to 25 grams. So for the solution, first we are going to determine the molality of the solution using this formula. M is equals to number of moles of solute divided by mass of solvent in kilogram. Then we're going to plug in the given to the formula. So we have 0.172 mole divided by 0.025 kilogram. So we cannot cancel the unit, but that is equal to molal. So when you divide 0.172 by 0.025, that will give you 6.88 molal. So for our step 2, for the solution, we're going to solve for the boiling point elevation. So our formula for boiling point elevation is delta T sub B equals to K sub B times M. So earlier we solved for the molality, so we can just substitute the given to this formula. So our K sub B is 0.512 degrees C per molal, and then we will multiply that to the computed value of molality a while ago, that is 6.88 molal. So you see, I cancel out this unit because it's the same. So the remaining unit will be degrees Celsius. So the next thing that you're going to do is multiply 0.512 to 6.88. So that will give you 3.52 degrees Celsius. For our step 3, you're going to obtain the resulting boiling point of the solution by adding delta T sub B to the normal boiling point of the solvent. So our equation will be T sub B equals to 100 degrees Celsius plus 3.52 degrees Celsius. Therefore, T sub B will be equal to 103.52 degrees Celsius. The addition of a solute in a pure solvent lowers the freezing point of the solvent. This effect has many applications. In cold countries, water placed in radiators of vehicles is added with ethylene glycol to lower its freezing point. Since water expands when it freezes, it can damage the radiators, so its freezing point has to be deterred. The amount of freezing point depression is given by the equation. The amount of freezing point depression is given by the equation delta T sub F equals to K sub F times M, wherein delta T sub F is the freezing point depression in degrees Celsius, and then K sub F is the molal freezing point constant for water that is 1.86 degrees Z per molal. And then M is the molality of solutions. Alright, so this time let us have sample problem so we can use the formula of freezing point depression. So our sample problem is determine the freezing point of the solution that has a molal of 6.88. So let us have the given for the problem a while ago. So for the given, we have the following. Molality of solution, that is 6.88. K sub F is equal to 1.86 degrees Celsius per molal. And then the unknown is delta T sub F. So our formula for delta T sub F is K sub F times M. So since we have the given, all we have to do is just plug in the given. So for K sub F, we have 1.86 degrees Celsius per molal, and then the molality is 6.88 molal. So you can just cancel out this unit and this unit. So we will have a remaining unit of degree Celsius. So what you're going to do is multiply 1.86 to 6.88. So in that case, when you multiply 1.86 to 6.88, that will give you 12.80 degrees Celsius. That's the value of delta T sub F. So the resulting freezing point of the solution is determined by subtracting delta T sub F from the normal freezing point of the solvent. Therefore, our equation will be delta T sub F is equal to 0 degrees Celsius minus 12.80 degrees Celsius. So T sub F will be equal to negative 12.80 degrees Celsius.